later on post and share. So welcome. We're about to work on a weight and balance problem. And I'm trying to share my screen to make sure that we're all looking at the same. So here is what I think you might be looking at. This question here, possibly. It says, refer to figure 35, determine the moment with the following data. We got an empty weight of the aircraft, which is 1,350 pounds, a moment of 51.5. That one says divide by 1,000. It says pilot and front passenger 340. It says our fuel is standard tanks all the way to capacity. Oil 8 quarts, and we got A, B, C answer choices. Do you think this is the question you're thinking, Christian?
That's exactly it.
Okay, cool. So it says refer to figure 35. What we typically find with a lot of these questions is that we're studying older questions, and then the FAA has updated their questions. So the figures may or may not perfectly line up, but let's see if we can get lucky today. It says figure 35. So here's the testing supplement. You can get this off the FAA's website. We also have it linked in our Blackboard site. And I'm hoping to find the table of contents so we can load up figure 35. Maybe I'll hit Control F for find, and we type in figure 35. Here's figure 35. It says airplane power settings. So another prime example where the FAA has changed their figures for us. We can see there's airplane weight and balance tables and graphs on these three figures beforehand. So we're probably going to be looking at one of those figures. I wonder which one. So let's take a look at figure 34 to see what it looks like. Well, it looks like a crosswind component chart. That says 36, there's 35. Here's 34, and here's 33 and 32. So depending upon which figure we use could affect how our answer comes out. So let's see if we can get more clues. Over here it says figure 35. I wonder what it looks like if I try to open it. I hope it just doesn't say missing figure. Oh, I don't even get any sort of picture, do I? What if I just try to click it straight out? Maybe so, it's thinking. See, I don't think I'm getting any figures today. That's kind of a bummer, isn't it? Well, we just got to pick one and go with it. So I'm going to explain to you guys. Oh, something's flashing on my screen here. Mason's trying to get in. We'll let him in. So we got to figure out which one of these we think is the most appropriate. How are we going to know the answer? This one says the empty weight is 2015. See that? That conflicts with the empty weight here of 1305. So I'm wondering if this figure 32 may not be correct. If you're a person that has questions about this one, figure 32, we did do a video about that one, and it's posted on there as well. I'm wondering if this one might be the better answer. So on this particular figure, it's given us like a max gross weight of like 2,300 pounds. So if we started off with an empty weight of 1,350, that might put us in the ballpark. It's telling us that the fuel maximum capacity be 48 gallons. It's telling us pilot and front passengers of 340. I don't know, I'm thinking this might be the best graph to use. We're just trying to use our best judgment here. So let's see if we can tackle any math associated with this, and hopefully it'll work out for us. Let's start with some really simple things about weight and balance. There's only two math equations for weight and balance. There's only two. WAM, weight times arm equals moment, and then mom's over weight, which means moment divided by weight equals center of gravity location. Or you can say the word arm. Okay, so there's only two math problems. We got it. So what are we going to do? We're going to build, there's two ways to do this. Let's start there. There's two ways to do this. We could do it with a graph method, which is what this particular example is asking about. I still prefer the table method, which is where we're going to do math. But this graph method is supposed to make it so we do less math. Okay, Cool. Well, with any one of these, you should really always start by reading the notes. So basically what's going on here, we have load, weight, pounds over on the left. We have the load moment on the bottom. Let's ask the question, what is moment? Moment is a way to measure force. Moment is a way to measure force. So the idea is that if you have a very long arm, like you're trying to break the lug nuts off of a tire to change the tire, and you would like a very long arm, a long breaker bar, you would apply the same force, but more force would actually be felt because of the longer arm. So that's what the whole moment concept is all about. Moment is describing the concept of a leverage. So when you get a longer arm, you might still have the same weight, pounds, but because the arm is longer, it's actually pushing down a larger amount of force, called that moment. So moment is measured in foot-pounds, pound-inches. It's a combination of both weight and distance. What you're going to find in aviation is that sometimes these numbers for moment can become very large numbers. So like if you was doing a weight and balance problem for a 747, like a very huge airplane, the numbers would become so large that it might make sense to scale down those numbers. And that's why you see these vocabularies of like divide by 1,000, divide by 100, divide by 10,000. What they are is they scale down the numbers so that way they're smaller numbers. It doesn't matter to me. You can choose to use the big numbers. You can scale them down for the small numbers, whatever makes you happy. Just you need to make sure to follow the same format throughout all of your math. Okay, so we talked about weight, pounds, we talked about moment, and what we're seeing is we're seeing 1, 2, 3, 4 different lines plotted on this graph as we compare weight, pounds to moment. The first is going to be talking about the front seat, pilot and front passenger. So in this example, we said that the pilot and passenger was going to be 340 pounds. Let's just double check that. It says, yep, 340 pounds. And then it says moment divided by 1,000, but then it doesn't actually tell us what that moment divided by 1,000 might mean. So we need to figure out that information for ourselves. So pilot and front passenger, and I can draw on this, so let's annotate. We said that we had 340 pounds. So over here is 300, there's 350, one box down would be 340, click, drag. Oh my gosh, it's not drawing a straight line at all. Clear that, clear it. Let's try drawing a straight line. Here we go. And 340, probably right there. There's my straight line. And I intersect that front seat, pilot and front passenger, right about there. So if I take that same number straight down, I'm getting a number of, well, there's 10, there's 15, what, 12 and a half. Each box might be worth, 2 boxes might be worth 1, so there's 11, there's 12. I don't know, somewhere around 12 and a half. Do you guys agree, disagree?
I have a question. Are you on the figure or are you like on the word problem still? Because I'm seeing like that you're still on the question for the problem. I'm not seeing if you're on the figure.
Aha, so thank you. There's something wrong with our screen share. Let's stop sharing the screen. Let's try it again. If I hit screen share and I hit this button, do you guys see the figure now?
Yeah, I see it.
Okay, we're doing better. We're doing better. Technology, we're fighting technology. Okay, so the idea is that we're analyzing this pilot and front passenger line. Thank you for that. And I'm going to try to draw a straight line to show you how you can do this without this less math. This is more of a graph method. So as I draw my 340 line over, it would intersect the pilot front passenger somewhere around here. I didn't get a very good straight line, but you get the idea. And then I try to bring it down as possible to get a straight line. And I get somewhere around 12.5. So what does that mean? It means if we put 340 pounds of human being in the front 2 seats, the pilot and passenger, it's going to apply a force down that is actually similar to 12.5 divided by 1,000 pound-inches. So you got to imagine like 12.5. Well, you see how there's 3 extra zeros, 1, 2, 3. So that'd be like saying 12,500 pound-inches. However you want to measure leverage, if you want to call it 12.5 divided by 1,000 to keep the number small, around 12.5, or if you want to use all those zero places and take away the divide by 1,000, then it would be 12,500. Did I say that right? Let's just draw it out. So if I hit text, what I'm explaining to you, and I'll just write it out in plain English, is that 340 pounds of force, let's say word weight, of weight in the front seats creates 12.5 divided by 1,000 pound-inches moment force and then 12.5 divided by 1,000 is really the same thing as saying 12, and then I need 3 decimal places over, so that 500. And that would be pound inches. Is that confusing? Is that making sense?
Would it be times 1,000 to get that number, sir, or
Sure.
Okay.
Yep, so you can just scale up, scale down, whatever you need to do, times, divide, but what they're doing is this whole divide by 1,000, they're just trying to create small numbers to work off of, which can be helpful, but could also be distracting. It just depends on how big the airplane is and how difficult your math is. So we've done this to begin with here, and so what I would really encourage you to do is just build a table. So let's try to start over and let's just build a table. Clear my drawings. And we're going to start with a text. And at any time, it's just the simple problem of weight times arm equals moment. Okay? And what happens is this is a graph. This is a graph format. So we have to do extra math if we want to find the arm. So weight, the first thing we need to count for is BEW. That's called empty weight, basic empty weight. It's going to have an arm location. And then, you know, when you equal that out, it will then create the moment. And that was probably given to us in the example. So that times the arm is going to equal the moment. Then what are we going to need to do? We're going to account for things like, you know, the front seaters, front seat weights, people, front seat people, how about that? People weight times the, you know, arm location is going to equal that moment. Then you're going to have things like the rear seat people weight times that arm location equals that moment. You'll have things like fuel. See, fuel can be in terms of gallons, but you really need to know the weight, the pounds, LBS. We know that fuel weighs 6 pounds a gallon. You'll need to know that information. Times the arm station that fuel is at, that'll equal the moment for that particular case. And only other thing left would maybe be like baggage. So whatever baggage pounds times the arm location for that particular example equals the moment. And then at that point, you can add together all the weights and all the moments. And then the total, we said mom's overweight, so the total moment divided by the total weight will equal our CG location. So this is what I'm setting up for you right now. It takes time to do math, so I'm just kind of really taking the time to explain to you all the steps that's going to be happening here. So we're letting Nicholas in the room. He's jumping on here. Okay, so now that we've done this, let's walk you through it. We said that the very first one is the basic empty weight of the airplane, and I got to keep clicking back and forth between these, which it doesn't let me do, so if I lose it, I lose it. I click, and it tells us that our basic empty weight is 1,350. Okay, so if we're 1,350, I'm going to click the button to go ahead and type that in, if it'll let me. There it is. There it is. Aha, good job. So our basic empty weight in this case is going to be 1,350. I'll just keep it as BEW for basic empty weight for you. 1,350 pounds. We just figured out the moment by using this graph. Since we had a graph format, we did it using the graph, but if you had had a table method, then you would actually have to use the arm number to take the pounds times the arms. But in this case, we get a moment of 12,500, and that's pound inches. You could label it as 12.5 moment divided by 1,000, or you could put the decimal places in there. It doesn't matter to me, whatever you guys want to do. And I think this blue color is a little problematic, so let's see if we can change our color, and maybe that'll help us as well. Cool. So that was us doing basic empty weight. Let's move on. It says the front seat people, well, those front seaters, they're going to be 340 pounds. Okay. And then we need to figure out what's the moment going to be for the front seaters. That's a great question. I'm glad you asked. So let's see if we can move this thing out of the way. And let's see if we can do some drawings and straight lines for our front seaters. Oh, we already did this. I screwed it up. Goodness. Let's bring this sucker back up here. What's supposed to happen, and I'm glad you guys, it should be right here. This is 12,500 pound inches, and that's going to be for the front seaters of 340 pounds. We did that earlier. That's what we did. What we don't know is the basic empty weight of the aircraft. So I think we're probably going to need to click to find out. It says 51.5. That was given to us in the information in the beginning of the problem. 51.5. So here, if I put 5.1, I could put 0.5, but I'm going to put comma 500, and I'm going to use the big numbers for my moments. So now we need to figure out if there's any rear seaters, if there's any fuel, if there's any baggage, so that way we can add up all this together to figure out the information. Okay, so now let's see what happens if we go searching for any more of this information. We need to know about rear seaters or fuel or baggage. In the question, it's telling us that we have fuel standard tanks at capacity. So if we study this figure here, our fuel at capacity looks to be 48 gallons. So our fuel at capacity is 48 gallons today. We know that fuel weighs 6 pounds a gallon. So 48 gallons times 6 pounds at 6 pounds a gallon is going to leave us with a pound. Oh, where's my calculator? Best thing to do is usually type these in so you don't screw up the math too bad. And even then, you can screw it up. 48 gallons times 6, I get a number of 288. So 288 pounds is the weight of 48 gallons of fuel. Now we want to know what's the moment. So what kind of force does 288 pounds create? So they've done it to us today with a graph. So here's the fuel. And so if I had 288 pounds of fuel, that would be right here where this marker is, which is why you could see if I was able to draw a straight line, that'd be 288 pounds. And then down here, if I go straight down, it's going to tell us how many moment, pound inches. And I'm just doing my best to draw a straight line. It's not perfect. Somewhere around in there. So I think we're going to call that 13.5, 13.6. Does anybody agree, disagree? No interaction. I think we'll call it 13.6. That's my guess.
I agree. My phone's just being weird.
Yeah, it's kind of hard to see these sometimes. So we think 13.6 is the correct answer. So we're going to click. And we're going to say that fuel creates a 13, in this case, comma 600 moment, which is pound inches. Okay. So what are we missing? At this point, I don't think we're missing much. I think we just need to do some math and add them all together. So here was our original question. Our original question says, determine the moment with the following data. We had empty weight, we've accounted for that. Pilot and front passengers, we've accounted for that. It says fuel, standard tanks, we've accounted for that. Now here we have oil, 8 quarts. So this is kind of a tricky question. They might be trying to trick you with this one. It's a kind of a history lesson for you. There's a lot of different types of empty weights. Years ago, they had standard empty weight, and they had basic empty weight, and then licensed empty weight. I actually set them in bad orders. Right now, the most current vocabulary word is called basic empty weight. But some of the older, like licensed empty weight or standard empty weight, some of those older vocabulary words, they may or may not include things such as unusable fuel, things such as oil. So with today's common technology, common vocabulary, I should say, with today's common vocabulary, basic empty weight, oil is already included in the basic empty weight. But in this case, we might need to do extra math involving this 8 quarts of oil. How would we know? Well, the answer is to read the figure. And so this figure itself is going to tell us that information. So down here, it tells us engine oil is 8 quarts, and it says 15 pounds at negative 0.2 moment divided by 1,000. So here's the note. The empty weight of this airplane does not include the weight of oil. So we're going to need to do extra math to account for that oil weight in this particular example. What you remember is that all of your weight and balance math is based off of the datum. So the datum is just a fancy word for reference point, a place to measure from. On a lot of airplanes, the reference point is called the firewall. So the firewall is the structure that exists between the engine and the cockpit. So if there ever was a fire in the cockpit, if there ever was a fire in the engine compartment, that the fire would not continue to move farther back to where the pilots are sitting in the cabin. So that firewall is the datum reference point, is what I'm guessing for this particular airplane. Why do I guess that? Because it says that the engine oil is a negative moment. So that the distance, the moment, the arm lever, the distance we're talking about for oil is a negative number because it's in front of the datum. Huh. So what's going to happen as we do all this math, we're going to have to do some subtraction math when it comes to oil, whereas we do addition math for everything else. Interesting for this example. I'm just about to point to add all these up, but before I do that, let's scroll down and see what's happening in the bottom of this figure. It's showing us a second graph where it's telling us about our total airplane weight and our total airplane moment. And we're going to use those numbers to input into the graph to figure out if we are within limits or not within limits. Okay, cool. So let's make some modifications to our notes here. Now that we have an idea of what's going on, we understand that there are no rear seats to account for in this particular example. We understand that there is no baggage we need to account for in this example, but we are going to have some oil we need to account for. And it's going to be a negative number. Okay, so we're going to follow our directions like we said down here, which is add together all the weights and all the moments. Okay, and then we're going to do that first before we start, because we need to, like they call it order of operations. We need to do our order of operations to take care of additions before we take care of subtractions. So after we do add together all the weights and all the moments, then we will subtract the oil. Okay, cool. So now that we're all thinking on the same page, let us do some math. Hooray for math. So we're going to add together all the weights and all the moments. So for the weights, we're going to have 1,350 pounds. We're going to add that to 340 pounds. We're going to add that to the fuel, which we said was 288 pounds. And we need to add the oil in because oil is a weight that pushes down. But I'm thinking that when we start to do the math for moment, it'll be subtraction math since it's in front of the data. I think we said it was 15 pounds, but let's double check that. Yep, so right here it says engine oil 8 quarts, which is 15 pounds, and it's at the station in front of the firewall. So if we screw it up, then maybe we needed to subtract the 15 pounds, but in my mind, I think we need to add it. So let's see if we add that 15 pounds as well, plus 15 pounds for oil. And I'm gonna get a total moment. This is the part where I pull out my calculator, and I'm just gonna type them up. I encourage you to type it into your calculator as well, because I might do math errors, and if you can catch me early on, it makes it more simple than if we catch it later. I'm getting a number of 1,993 pounds for my total weight. Does anybody agree or disagree that's following along doing math?
Agree.
Cool, awesome.
Agree.
Cool, so that was us adding together all the weights. Let's try to add up some of the, let's try to add up some of these moments. Okay, so now we have moments. So in our example, we had 51,500 pound inches plus 12,500 pound inches plus 13,600 pound inches. But we also got to get that oil in there. Well, let's subtract that one later because that'll be a little more tricky. So let's do that. So here's these in our moments. Everybody's following along with their calculator, typing it in. So I'm not the only one in case I type in something wrong myself. I'm getting 77,600 pound inches. That's the total moment. That's before oil math. Okay, I'm getting a pop-up here. What's going on? Let's click a button here. Click. Kai is trying to get in, so here comes Kai. And I click this button to get back. Okay, so the oil, they say that, yeah.
I said, sorry about that. My computer did one of those like random update things, and it just decided it was going to restart itself. So I apologize.
Technology, man, we fight it every day. So yeah, we are recording. This will go back up here as well, so you guys can review this later as well. The whole idea is that we need to now subtract the oil moment, because the datum is the firewall and the oil is in the engine, which is in front of the firewall. So that's a negative number according to this. I'm thinking that's what we need to do. Let's see if it works. So we had 77600 total moment. We think that the oil accounts for negative 0.2 divided by 1,000. So if I scale it back up, or like Christian says, multiply by 1,000, that gave me 3 more decimal places. So I think that's going to be 200, negative 200. So the oil math is that we were at 77,600, but we're going to subtract 200 for that oil that's in front of the datum. And that's going to give us an answer of 77,400. And that's pound inches, and that's now our total moment. Like that. Okay, cool. So now we've accounted for this. So what's really left to do? If I was doing a table method and I was doing math, I would just, take this moment, divide by, take this moment right here, divide by this weight. So let me separate those so they're more simple for you. I would take this total moment, 77,400, and I would divide by weight. And then it would give me the CG location. That's what, you would typically do if you wanted to know the CG location. Just so you guys can see how that's done, I'll go ahead and do that for you. 77,400, division symbol, 1,993 gives me an answer of, just type it into the calculator, 77400, division symbol, 1993, and it gives me a number of 38.83. We think that's where the center of gravity is located. Could be right, could be wrong. I don't know. That's what I'm thinking about right now. But in this example, they're actually not asking us to do that math. I just demonstrated that to you right now. What this question's actually asking is for us to use the chart here. So I think that's, so what we're seeing is if we want to do this chart to do this particular problem, it's telling us that we have a, I'm just going to look at it here. It says our total weight is 1993. So I'm just going to write that on my scratch piece of paper in front of me. 1993 is my pounds. And it says my moment is 77,400. So I'm just going to write that on my piece of paper in front of me. And that's my pound inches. Okay. So what we're going to do is we're going to try to see what it looks like to line those numbers up with the chart. Just pull those out of the way. And I'm going to draw in this case. Okay. It said our weight was 1,993, which is dang near 2,000. So here's about 2,000. We're going to be somewhere along that line, roughly. And then we said our moment was 77,400. But this is actually a divide by 1,000. So you can just call it 77.4 for today. So 75, and here's 80, so 77.4 would probably be somewhere right around here, I think. And I'm doing my best with technology, something like that. So where these two meet, that's going to be where this airplane is located, center of gravity wise. So we're probably like right around here or so. It's what it kind of looks like to me. We're kind of on the edge of utility and the edge of normal. Let's see what that helps us out as we try to analyze the question. It's telling us that the correct answer is 74.9 pound inches. Determine the moment with the following data. So I had 77.4. I actually had an answer that's closer to C, but they like to have the answer of B, 74.9. So we're getting an idea of how to do some of the weight and balance math. I wonder what. Yeah.
See, I've had the same problem. I would look. There's a couple of those problems. One of the practice tests that you posted, I went through it, and I mean, it was the same thing. It was given an answer that was not what you get adding up all the moments.
Yeah, it's a bummer, you know, and I
was going to say I had that exact same problem as well. Now, I bought one of the softwares that actually explains it to you, and they said that the fuel capacity was actually 11. The moment was actually 11 instead of 13. So if you put 11 as a moment, you actually get 74.9. But where they got 11 from, that's the mystery.
Yeah, like where they get, why aren't these numbers in, like, you know, the test supplement or something like that when you're going through this?
So I'm sorry to be the one to tell you this, but the FAA test bank is not perfect. There are a lot of misprints. There are, you know, typos. I've literally seen questions where they have selected the incorrect answer choice, and that's supposedly the correct answer. And I'm sitting here racking my brain with some of it, and I just suddenly have to memorize the incorrect answer just to get through the test. It's a bummer. It's not right. I am doing my best job to try to explain it to you and work your way through it. You guys are telling me that the secret, that the answer is that suddenly we're supposed to get the answer of 11 for our fuel capacity, but that really doesn't make sense because here it's, oh, look at this. It says maximum usable fuel. If you have an airplane that has standard tanks, which is the single star, then your max is 38 gallons. If you have an airplane that has long range tanks, which is a double star, you get 48 gallons. So maybe that's what's throwing us off on this particular question. So when I study this, it says what? It says standard tanks. Are you guys seeing what I'm seeing now?
Mm-hmm.
So I think that the answer to this problem involves us using the standard tanks, not the long range tanks. So it did us, hopefully it won't be too difficult since we've already put all the math problems out there for us. And what I would correct us here on is that hear this note here, and it's my own thing, you know, I need to read the notes. We all need to read the notes. Maximum usable fuel for the standard tanks is the single star, which is 38 gallons right there. So at 38 gallons, you know, straight over here is going to be our weight, and then straight down is going to be our moment. So now if I grab all our math that we've been working on, let's try to plug in some of those numbers and see how our answers might change. So we said the fuel, instead of saying 48 gallons, we're going to say it's 38 gallons. Ah, I screwed that up. Come on. Click, click, click. Yes. We said our fuel instead is going to be 38 gallons. At 6 pounds a gallon, just type it into the calculator, make life easier on yourself. 38 times 6 equals 228 pounds. Okay, and then we said that it was actually going to be 11,000 for our pound inches moment. And just to verify that, I come over here in my chart. Yeah? You wanted to speak up. So here's why we're saying it's 11. It really kind of looks more like 11.2 to me, but not quite 11.5, maybe 11.2. I think I'm going to go with 11.2, but if Christian says that it was 11 in the book, then maybe I should just go with that. I don't know. I guess I'm just got to pick one. Hope it's close. I think it's 11.2. So now we need to add together all the weights, and instead of being 288, we think it needs to be 228. So that's going to change our answer. So we're just going to add up all of our weights. 1350 plus 340 plus 228 plus 15. I get 1933. Okay, moments. Well, my moment for fuel has changed. Before my fuel moment was 11, I mean, now it's 11.2, which we think was here 13.6. Yeah. So let's change this to be 11.2. So then we have a moment of 51500 plus 12500 plus 11200 equals 75,200. And then we think that because the oil is in front of the datum, we need to subtract 200 from that. So that leaves us with 75,00. Okay. And then if we were doing old-fashioned math, because there are going to be other problems where you do old-fashioned math, then you would just take the moment of 7500, divide by the weight, which is actually 1933. And just to do that math for you, just to show you how it's done, because there'll be other problems where you do that. 1933, you would get a CG location of 38.79. Okay, so now that we've done this, we should take a look. And I'm going to hit the annotate button. And I'm going to So let me write these numbers really quick on my scratch paper just so I don't lose them. The number was, my total weight was 7,070, no, my moment. My moment was 75,000. That's my moment. Divided by my weight, which we said was 1933, and that'd be my pounds. Okay, so let's see if we can move all this chicken scratch out of the way that we had to do for math. And then I'd like to hit the eraser button and erase this line and this line. And let's try to plug those numbers in and see what they look like. We said that our moment was 75,000, which is the 75.000. So here's 75, and I'm doing my best to line it up. The best thing for you to do is use the straight edge of a piece of paper. So when you have the actual testing supplement book in front of you, just pull out a blank piece of paper and use the side of your straight edge, and you can line them up a little easier that way. And then we said that the weight was 1933. So not quite 19 and a half, 1933, maybe somewhere around in here. Do your best job. And so now it's looking like our center of gravity is actually in the utility category, not necessarily the normal category. So there's a lot of airplanes that if you wanted to do some like spins and some of those other maneuvers, you might legally be allowed to do it in the utility category, but not necessarily the normal category. So that could be important weight and balance information for you if you're about to go do some test pilot maneuvers. So let's take a look at that original question and see if this helps out any. So now we're getting that number right there. So very good job. This was the kicker that bit us today, was that we needed to pay attention to the word standard tanks instead of long range tanks. I know it's confusing. I know it's time consuming. I hope this is helpful. Any thoughts, questions about this weight and balance math problem?
That makes sense.
What I really want to tell you guys is that when you take the real FAA written exam, there's going to be like 3 types of questions that could possibly come up. You could have a question come up that's just like, wham, bam, thank you, ma'am. Like it's super easy, super simple. You know the answer. You just click the answer and move on. Awesome. There's going to be questions come up which are a little more difficult. You think you know the answer, but you're probably going to have to open up some sort of figure. You're going to have to do a little bit of math. Skip it. And then there's questions like that one that come up that's like, wow, this is a big question. I mean, it could take me a half an hour, if not a full hour, just to tackle this one question. Well, that one question is still just worth the same percentage as all the other questions. ABC multiple guess. You got a 33.3% chance you might get it right just by dumb luck. So it's like a test taking strategy that you don't want to burn out your mental power. You don't want to burn out your capacity. You don't want to, frustrate yourself by attacking that problem when it comes up. When you recognize that that's the problem you're looking at on the screen, you skip it. And you skip it and you get through all the questions that you can that you already know the quick answers to. And then when you come back around and you start focusing on those more difficult problems, then you have an idea of how much time you really have to invest on one of those really tricky problems. Great. So that's been us doing some weight and balance math. In addition to this weight and balance problem that we just went through here, when you go to that finals folder, you can find another weight and balance problem or two that we covered during some of the office hours, if that's helpful. I'm looking at our clock. There's no reason for human needs that nobody has to, pee their pants. So we're going to take a little bit of a break. We'll be right back. And we said that we wanted to do a little bit of flight planning and reviewing of the final. So we'll be back in 10 minutes. Are you guys hearing me all right?
Yes.
Awesome. Well, maybe you found some relief, maybe you found a snack, you had a little bit of a break, thought about something else for a minute. We're coming back. The idea is that, we've had a few different requests of how we could spend some more of our time. We had one idea of doing some flight planning, might involve some wind math in the E6B. We had another idea of covering some of the questions that, like on the final exam. So plan of attack on my end, I have two computers going on here right now. So I'm streaming with you on this computer. And then I have another computer up over here that has the test open up. So what I would plan of attack would be is that I'd walk through some of these questions, like a little final prep, if you will, give you an idea of what some of these questions might be, what some of these topics might be for some of the questions that are going to be on your final exam. And I'll go through some of those. And then after I cover and give you a heads up on some of the questions for the final, then I can cover a flight planning question that involves math. Some of these questions are more in depth and they take more time. So what I would say is that, there is a video up that was recorded during office hours over the past 2 weeks. So when you go to the finals folder, you can see videos. There's also posted in the announcements section. And there's a video already up there that we did during office hours that's going to cover some flight planning and some wind math. But I don't mind going through some of that with you today. I think what my plan of attack is going to be is go ahead and cover some of the actual questions for the final. And then we'll look at our time. And I don't mind going over. But I don't want to hold anybody up if they need to get on to another final or something of that nature. So if that seems to be a pretty good plan of attack, then we could go with that. I don't want to leave anybody unanswered questions, though, if they're thinking about something else. All right. Well, it's no secret you're about to have a final exam. I got to open up right here. It'll scramble the questions and scramble the answers on your end. But on my end, the first question is asking about medical certificates. So you're going to need to know like the durations of the medical certificates. So, if there's pilots under 40, if the pilot's over 40, if they have a first, second, third class medical, and they want to use whatever types of privileges, how long would those privileges last? That'll be a question. You'll have a question about center of gravity location, where it'll ask, forward center of gravity versus aft center of gravity. Which one of those would create more stable? Which one of those would create more maneuverable? So center of gravity location, does it affect maneuverability? Does it affect stability? Forward CG versus aft CG. Here's a question. This would be something from chapter 1. It's talking about preventative maintenance and mechanics. And what you'll need to know here, it's like if they're saying that preventative maintenance gets performed on an aircraft, what kind of paperwork is required? That's the question on the written exam. And the correct answer is the signature, the certificate number, the kind of certificate held by the person approving the work, and description of the work must be entered in the aircraft maintenance records. I'm literally reading to you word for word the correct answer. A lot of the other answers are they sound very good answers. But the reason why this is the most correct answer is because it has the signature, the certificate number, the kind of certificate held by the person. Because you're a private pilot, you could legally do preventative maintenance. But if you are going to change a tire or do some preventative maintenance, then you would have to enter your information in the maintenance records for that aircraft and sign off that you completed that work. So that's going to be the best answer choice when it talks about maintenance records. Here's a question that's talking about spatial disorientation. What often leads to spatial disorientation or a possible collision with the ground or obstacles if you're flying under VFR? And all the answer choices sound good. They all sound good. The best answer choice here, according to the FAA, is continuing flight into instrument conditions. So the idea is that if you're a non-instrument rated pilot and you continue flying into instrument conditions, well, then you're probably going to set yourself up for spatial disorientation, collision, bad things. So, you know, for us as VFR pilots, they'll ask you this question on the day of your check ride. They say, what do you do if you inadvertently fly into a cloud, inadvertently get in instrument conditions? The answer is 180-degree turn. Standard rate turn should take 60 seconds. Turn around, go back to the area you came from. If you came from an area that was VFR, get back to the VFR area. We're gonna have a question that has a picture of a weather depiction chart. So we covered that in some of our weather chapters. And you gotta be able to look at this weather depiction chart, read the legend. It's talking about if it's a shaded area, it's IFR. If it's a contoured area, it's marginal VFR. If it's an open area, it's VFR. So you need to know the definitions of IFR versus marginal VFR versus VFR, and be able to look at the weather depiction chart, figure 18, to figure out which area is reporting what kind of conditions. Here's a question about load factor, maybe chapter 2 or 3. I guess it might have been 4, I can't remember, but load factor, and it's telling you that it's a math problem, if you will. So there's an airplane that weighs so many pounds, and they're doing a 45-degree bank turn. How much force is the airplane required to support? So it's a math problem. They have a picture of a load factor chart, and you look at your 45-degree bank angle to figure out the load factor at 45 degrees of bank is 1.414. It's the information written in the chart in front of you. They already told you the airplane weighed 4,500 pounds, so you just times the 4,500 pounds times the 1.414 according to the chart to figure out how much load is going to be required to support for that load factor. You'll have some questions about the sectional chart. So I think that we've talked about the legend. Remember, we put the legend up on the screen when we were in class together, and we would have the legend, all the different symbology, all the different symbols on the legend. So, you know, it'd be really handy to study the legend. Now, here's a pro tip for you. Pro tip. This question tells you to reference figure 23, and it asks, what does this symbol mean at this certain airport? Well, what the question does not tell you to do is to reference the legend. So you are smarter than the average bear, and what you can do is in your supplement, you know, whether you're using a digital supplement or whether you have a physical supplement that you purchase, at the very beginning, I think it's actually literally the first legend is the legend of the sectional chart. And so all of a sudden you could, you know, look at all these different symbols and literally look up the answer if you want to go to the very first legend in the book. But it won't tell you to reference the legend, it'll tell you to reference the figure. So the question will tell you to go reference figure such and such. What does the symbol mean? And if you don't know the answer, you could go and open up the legend and look up the answer. We'll have a VOR question, which is one that I literally covered in class with you guys last week, I believe. And so I opened up the actual VOR. It was a PowerPoint presentation that I put together, and I drew the lines and we cross-radialed the VORs. So, you know, you'll have a VOR that's tuned to a certain VOR station. You have a certain receiver indication in your cockpit. What is your position? Which VOR is correct? You'll have an airspace question. Airspace is a huge topic. I failed a real deal check ride over airspace. It was a bummer. So if you don't know airspace, you know, it's going to be an issue. You need to know airspace, you know, cloud clearance, visibility requirements, echo versus Gulf airspace. This particular question is asking about Bravo airspace. So you need to know about airspace. And this particular question is also asking about when you read the airspace on the map, on the chart. So like, you know, if it's a Bravo airspace, you need to be able to figure out what's the floor of the shelf, what's the ceiling of the shelf, how high does this airspace go, how low does this airspace go? Are these altitudes AGL, are they MSL? So you'll have some airspace questions involving reading the sectional chart for this particular type of airspace. There's a question about symbology. So again, that legend is your best friend. So it'll tell you to reference figure 25, and you'll open up figure 25, and it's a sectional chart, and it'll ask you a question about this VOR facility. Like, oh, is it a VOR? Is it a VOR TAC? Is it a VOR DME? And it just has a blue VOR symbol with a square around it. And you need to know what that means. And if you don't know what it means, then you can open up the legend, which is not, the question does not tell you to reference the legend, but you can, it's fair game, open up the very first page of the supplement and you'll find the legend. And if you didn't know the answer, you could literally just look at the legend to see what that blue VOR symbol means when it has a box surrounding it. It means it's a VOR DME. We have another airspace question. So it'll tell you to reference a figure. You'll open up that sectional chart and you'll look at this particular airport in question. And maybe this airport has a fuzzy magenta ring surrounding it. What does that fuzzy magenta ring mean? Does that mean it's a Gulf airspace? Is it a certain altitude, 700 AGL, 1200 AGL? Is it Delta airspace? What does that fuzzy magenta ring mean regarding airspace and airports? You'll have a few questions like that. Here's a question about Zulu time. So if you're going to depart an airport, you know, in a certain time zone, and the flight lasts so many hours, you're going to land in a different time zone, what time will you land? And then you just got to pay attention because are you going to land, you know, is the question asking, are you going to land in Zulu time? Is it going to be in Mountain time? Is it going to be in Pacific time? So we had a few of those questions in our chapters, and we went through some of those when we went through them as well. So use simple math. Try to keep your labels correct. That's the best thing I can advise you, is keep your labels correct. Are we talking about Zulu time, Pacific time, Mountain time? We have a question about reading the altimeter. So I think that was chapter 2. You know, refer to figure 3. What does this altimeter indicate? What altitude does this altimeter tell us? Reading the altimeter. We have a question about fuel consumption, which I think is one of the ones that we covered on our presentation last week, where I opened up the figure and I showed you what the gallons per hour fuel burn is, and if you're going to go on a flight, how much fuel are you going to actually burn. So we covered that one last week for sure. We have a question about a crosswind. So it's a crosswind chart, and the idea is that what you do is you figure out the difference of the center line of the runway versus where the wind is coming from, and that's how big the crosswind angle is. You know, if the crosswind angle is 90 degrees, that's a perfect crosswind. It's all crosswind. If there's a 0 degree angle, then the wind is straight down the runway. There's 0 crosswind. And crosswind chart. We had a little bit of experience with that, some of our earlier chapters. We have a question here from chapter 2, I believe, which is talking about your instruments. You need to understand what the airspeed indicator looks like and what all the markings on the airspeed indicator mean. So like, what does it mean if you're at the bottom of the green arc? What does it mean if you're bottom of the white arc? What if you're at the top of the green arc? What if you're at the top of the white arc? The yellow arc, the red radial line. So you need to understand all the markings of your airspeed indicator. And a lot of people missed this early on, and we've covered it since then. We covered our tests, you know, thoroughly after each time. But remember that when the FAA says the words the bottom of the white arc, they're actually describing the lower numbers. So like those slower, lower numbers. That's what they mean by the bottom of the arc. If they say the upper end of the arc, they're talking about the higher, greater, larger numbers. We had a question we covered last week in class together where we opened up a chart and we did takeoff distance data to clear a 50-foot obstacle. So you'll probably see that question again. We have a question here that is review. You're going to get a picture of a windsock and an airport diagram, and you got to figure out which is the correct runway and how to enter. Is it left-hand traffic, right-hand traffic, looking at the segmented circle. You'll have a question where we involve the sectional chart and you're approaching the airport. I think this is actually a question that Christian brought up, early in the semester. And I think it involves like the AFD, the Airport Facilities Directory, and you're approaching the airport from a certain direction. What's the correct frequency to call to get some flight following? Another AFD, Airport Facilities Directory question, where it's describing where is the airport located in relationship to the city center. So we had a PowerPoint, we covered that, thoroughly back, early in the semester, where we're reading the Airport Facilities Directory. Again, pro tip, if they tell you to reference 52 and you're sitting there looking at an Airport Facilities Directory and you can't necessarily remember which pieces of this information tells me, then you could open up the front of this chart supplement, this book that they've given you, and in the front there are legends, and that same Airport Facilities Directory legend that we covered thoroughly in class is literally printed right there, so you can look up the answer. We'll have a question. Again, this is one that we covered in class where we talked about teeter-totter, which is very similar to what we just did about weight and balance. Remember, there's only two equations: weight times arm equals moment. And then moment divided by weight would be center of gravity location. So it's one of the questions we covered last week. You'll see that one again. Again, it's another question that we covered last week in class. We're talking about wind. We're flying a rectangular course. And so wind correction angle, sometimes you angle into the wind. So it could create either a more or less than 90-degree turn. We got a question here that is about load factor limitations. So that would be they call it a VG diagram. So velocity versus G forces. So the VG diagram, you'll have a question about VG diagram. What's happening? See it. We're here at the airport today. We got other flight instructors out here exercising airplanes. We're getting these airplanes all warmed up for you all. Let's see. Yeah, so load factor. So a VG diagram, figure 72, it says, is the VG diagram. And so VG diagram. We have some questions here about beacons. So remember, like all the different beacons, what is a civil airport? What is a military airport? What's a seaport? The different beacons for the different types of airports. Question about Delta airspace. What kind of minimum entry requirements do you have to have for Delta airspace? You have a question about that. We have some definitions. So definition, about a type of thunderstorm that's a narrow band of active thunderstorms. Our definitions from weather. Here's a question. It's kind of like a common sense question, but it's kind of like a question just about choosing the safest answer. It gives you a lot of math information, but you actually don't have to do any math for the question. So it's going to tell you that you're landing on a short runway and you're at max gross weight. You got all these passengers, you got all these baggage, you got all this fuel, you got all this weight, and your takeoff requirements is that you barely have enough runway. What should you do? A, B, or C? Should you wait until it gets colder so you have better performance? Should you attempt the takeoff anyway? Should you maybe just go try it with only one pilot instead of multiple people? I mean, the safest answer is that, hey, if the margins are too close, then you should make a no-go decision and attempt the takeoff again at a different time. So we know that hot air, less dense air hurts our performance. The engine breathes just like a human does. and your engine is not breathing and creating very good power when it's super hot. We got a question about wind shear, temperature inversions. We've covered a lot of that. We got a question about the richness of mixture. So remember, we talked a lot about what the difference of a lean mixture means versus a rich mixture. And we need to know what are the common conditions associated with rich versus lean. So, you know, remember that like extra rich usually means it's a cooler running engine. Extra lean typically means that it's extra hot running engine. And what kind of issues could come surrounding those situations. We got a question about AC advisory circulars. You know, are they binding or not binding? We got a question about entry requirements for Charlie airspace. A lot of airspace questions. So you need to know about airspace. Again, another airspace question. This one's talking about the special use airspaces. So you need to know the difference of, like, you know, the warning area versus the prohibited area versus the restricted area versus the military operations area versus the alert area. A lot of airspace questions. Another question about mixture, you know, rich versus lean. And us as pilots, what could we expect if we screw up with the wrong mixture settings? Question about clouds and how they're classified, how clouds are classified. We just had that on our last test. Detonation, question about detonation. We had a lot of those questions earlier in the semester. A question about night flying, and we had this question on one of our previous tests. It's talking about how you observe, you know, a steady red light, a flashing red light, same altitude. You know, what does this mean about this other airplane? And we had that question in class, and we covered it as well. Question about load factor. How does load factor affect stall speed? How does load factor affect stall speed? You should know that. Here's a question about doing a run-up, and you're doing a run-up at a high elevation airport. Call that high density altitude airport. And it's a rough run up. So what that means is that you've got a mixture that is too rich. So what should you do? You know, you might want to try that run up with a more lean setting. High density altitude airport, yeah. We got a question about the documents that you need to carry as a private pilot. So what documents do you need to carry as a private pilot, and who would you possibly ever need to present those documents to if they request it from you? We talked a lot about condensation. So the process of condensation. You know, we don't want condensation to happen in our fuel tanks. We got some constant speed propeller questions for you. So variable pitch propeller, constant speed propeller. You need to be able to have the correct combination. So, you know, is it like, you know, a low pitch? Is it a high pitch? Is it a high RPM? Is it a low RPM? So we talk about fine and coarse pitches, and we need to know what they correlate with each other, how they correlate together. We got a question involving math. It says if we were traveling at 114 knots, how far are we going to travel in 7.5 minutes? So remember knots, K-N-O-T-S, it just simply means nautical miles per hour. So it's a math problem. If you're traveling 114 nautical miles an hour, well then how many miles are you going to cover in 7.5 minutes? Another constant speed propeller question, constant speed propeller. Another constant speed propeller question. This question is actually talking about the temperatures of the engine. So, you know, remember there are certain actions that a pilot can do to cool an engine. I think we went over those in class. There are 4 actions a pilot can do to cool an engine. So we've had this question before. You're seeing it again. Here's a question about currency and recency. So talking about flight reviews, how often is a flight review due? I think that was a chapter 1 question. Flight reviews due every 2 years, if you remember correctly. Biannual flight review, 24 calendar months. Okay. This one's kind of a tricky question about air temperature. How does air temperature affect density altitude? So basically density altitude, you know, it's how the airplane performs regardless of real altitude. And we know that warm air is less dense than cold air. So if it's an extra hot day, that means the air is less dense, which correlates to a high density altitude. Bad for performance. We got a question about weather. It was the most recent topic. Thunderstorm activity. What kind of phenomenon might we see around thunderstorms? We got a question that involves airport signs and markings. So remember our airport signs and markings. What kind of publication might you use to look up signs and markings information? We got a private pilot privileges and limitations question. There's a fancy vocabulary word a lot of people say called prorate share. So like, you know, as a private pilot, you can't charge somebody to take them flying. You need a commercial pilot certificate before you can charge for your services. But as a private pilot, you can have them pay their own fair share. That's called prorate a share. We got some compass questions. Remember from chapter 2, there were a lot of compass questions. So you'll see some of those compass questions again. We got some aerodynamics questions about stall and spin. Aerodynamics about stall and spin. Aerodynamics question about drag. Remember the different types of drag, what affects them? Induced drag, parasite drag. What kind of speeds are they most prevalent at? Drag. We got a question about the Airport Facilities Directory, the AFD. So we studied the AFD. Question about NOTAMs. Temperature inversion, another question about temperature inversion. Here's a question about the engine. The heat that comes off the internal engine. How do we cool an internal engine? More compass questions. A question about dual ignition systems, so our magnetos. We got a question that's talking about why do we have a dual ignition system? Why do we have 2 magnetos? We got a question about carbon monoxide. So carbon monoxide is a bad thing. I mean, you know, people have carbon monoxide detectors in their house. We have them in our airplane. Carbon monoxide is poisonous. It's a poison gas. It comes through our exhaust system. And you need to know that carbon monoxide poisoning is worse at higher altitudes. Why? Because at higher altitudes, there is less air for us to breathe anyway. So all of a sudden, if we're getting poisoned by poisonous air, our susceptibility to carbon monoxide poisoning increases with altitude. We got a question about true north versus magnetic north. Remember, that's called variation. We got a question about traffic pattern, which runway to choose, how to enter. Remember that you want headwind. Your goal is to have headwind. Airspace question, Delta airspace. You need to know about Delta airspace. Question about aerodynamics. So remember the turning tendencies of the airplane. Remember we had P factor, torque, spiraling slipstream, gyroscopic precession. So remember those turning forces and trying to figure out if it's going to be a left turning force versus a right turning force. Question about collision avoidance. How does the FAA teach collision avoidance? And in particular, what do they teach for at night? At night, they say that, you know, we should use our off-center viewing for nighttime collision avoidance. Here's a question that would be from chapter 1. It's talking about a type rating. And so what you're learning is that a type rating is required for 3 different instances. It could be if the aircraft weighs more than 12,500 pounds, if the aircraft is jet powered, has a jet engine, or if it's specified by the administrator, so if the FAA says so. So those are the three reasons why a pilot would be required to have a type rating. Type rating just means it's an extra check ride. You have to have a special extra check ride on that particular make and model aircraft. That's what a type rating is about. So we don't have a type rating for a Cirrus SR-20. We don't have a type rating for Seminole, Piper Seminole. You know, you'd have a type rating for a 747, you know, if you want to learn to be the pilot for that airplane. We have a chapter 2 question talking about the instruments, like what instruments is the static port connected to? What instruments is the pitot tube connected to? Which instruments are gyroscopes? So you have a chapter 2 instrument question there. Here's a question. The responsibility for ensuring that the maintenance personnel has made the appropriate entries in the maintenance records. That is, whose responsibility is that? They say it's actually the owner operator. It's their responsibility to make sure that the work has been done correctly, that somebody's entered the information correctly into the maintenance logs. Pilot and command is a tempting answer choice, but that would be more like whose job is it to, you know, make sure the airplane's airworthy and legal to fly versus whose responsibility is it to ensure that the airplane's kept in an airworthy condition. So owner operator. We got another question about gyroscopic precession, torque, P factor, you know. Is it going to make us have a yawing motion? Is it going to make us have a pitching motion around the vertical axis against the horizontal axis, the lateral axis? So we covered that a lot in class about stability and the types of motions we can have around the different axes. We got a question here about currency. You know, we've heard a lot that, you know, us pilots, if you want to carry passengers, you need to have at least 3 takeoffs and landings in your logbook in the preceding 90 days in the past 3 months. And here you're having a question about if it's a nighttime currency. So if you want to take passengers flying at night, then you need to have those 3 nighttime landings in your logbook. And the FAA wants to make sure that it's good and dark when you become current in those operations. So the definition for the FAA for currency is that those landings for currency had to have occurred at least, you know, in the time period 1 hour after sunset to the time period of 1 hour before sunrise. We got another airspace question, Charlie, C airspace. Again, another question about the axes of the airplane, telling the difference between the longitudinal versus the lateral versus the vertical axis. I got a question about PIREPs. What kind of information is good for PIREPs? You know, things like cloud tops, icing, turbulence, those are the big buzzwords for PIREPs. You know, there's lots of different definitions we've covered in this course. And right here, they're talking about pressure, altitude, density, altitude. It's all the same if conditions are standard. So if it's standard pressure, if it's standard temperature, if it's standard, then pressure, altitude is density, altitude. So pressure, altitude is a number that we can use for performance. Density, altitude is the altitude the airplane performs at regardless of real altitude. If you're a definition person, you remember pressure, altitude is actually height above the standard datum plane, whereas density, altitude is pressure, altitude corrected for non-standard temperature. You got more airspace questions about restricted areas. You got some questions about turbulence. What's the pilot supposed to do if they encounter turbulence? Question about weather, about air masses. Remember to pay attention, like, does the question say it's a stable air mass? Does the question say it's an unstable air mass? And if you can figure out what kind of air mass you're looking at, then you have a better idea of what kind of clouds might be produced. Remember, cumulus clouds are less stable. Stratiform clouds are more stable. I got a question about sea breeze and land breeze. Got a question about what documents you need to carry on your person as a private pilot. Remember, the 3 documents you got to carry is your medical certificate, your PAL certificate, and your government issued photo ID. Got another weather question about convective sigmets. This question is kind of tricky. It says, what information is contained in notices to airman publication, NTAP? And the correct answer is current NOTAMs D and FDC NOTAMs. So you got a NOTAMs question. And what you're learning is that after the NOTAM exists for so long, it will get published in this publication. And so all the current NOTAMs would be in that publication, Notice to Airman publication. We got a question about all the different altitudes. If you remember earlier on, we talked about all the different altitudes and you had to define them all. So you got to know the difference between the different altitudes. We got a question about land and hold short operations. We got a flight controls question. You know, you got to be able to tell the difference between an aileron versus a rudder versus an elevator. And then you got to be able to understand what action is created when you push on that flight control surface. So, you know, is it the aileron? Is it the rudder? Is it the elevator? Which one of these motions creates a yawing motion? Which one of those creates a pitching motion? Which one creates a rolling motion? And around what axis? We got an aerodynamics question. We've had this one before on our test before. The relationship of lift, drag, thrust, and weight. We got an airspace question. If it's a delta airspace on the chart, what happens when tower goes to bed for the night? If it's a part-time tower, what happens to that airspace? We got a wingtip vortex, wake turbulence question. The procedures to avoid wake turbulence and vortexes. We got a question about flying a course. So like if you're flying a, you know, westerly course, if you're flying an easterly course, what's the correct altitude to fly at? Remember, oddballs fly east. So if you're flying an easterly course, it should be like a odd plus 500, 3,500, 5,500, 7,500 MSL if it's an easterly course. If it's a westerly course, 4,500, 6,500, 8,500, and even plus 500. We got a question asking about density altitude. So we know density altitude, we're talking about air that is less dense. We're talking about air that is thin. We're talking about bad performance. High density altitude is bad performance. So like what combination would create high density altitude? What kind of combination would create bad performance? Well, that'd be a hot temperature. That'd be a high moisture content. That would be a low pressure. Another question about the instruments. What's going to be affected if the static ports get clogged? Different question than what would be affected if the pitot tube gets clogged. Question about ADs, airworthiness directives. How do we know if an airplane is complying with ADs? It's in the maintenance records. It's in the maintenance records. Got a question about seatbelts. When are seatbelts required? Seatbelts are required for taxis, takeoffs, and landings. Common question. You'll hear that one again and again. And then the last question, I'm sitting here looking at the final, is if you had an airplane that's overweight by 90 pounds, how much fuel must be drained? And I'm pretty sure we covered that one in our last week when we did math. Remember, fuel weighs 6 pounds a gallon. So that has been me walking through question by question, you know, all the topics, the ideas, things that you might want to think about before you push the go button on the final. I had a question from Alec earlier about doing some flight planning, so I don't mind making a transition that way. If anybody's burnt and they need to head out, you know, for something else, there is flight planning videos up from the office hours from the last few Fridays as well. But before I start making transitions, do you guys have any thoughts or questions or anything that you wanted to ask after I just covered 90 questions with you?
No, I don't have any questions.
Thank you for the participation. Thank you. Okay. So we have just reviewed the 90-some questions, the ideas of things that you're going to experience when you push go on that final exam. And then Alex said he wanted to talk a little bit about flight planning. So again, there is a video up right now where I cover a very lengthy flight planning one, but I got you right here in front of me now. So do you have a particular question you're asking about, Alec, or what are you thinking?
Just one of the ones where they use the E6B. I've watched some YouTube videos and I've peeked at your video, but it's just kind of like, maybe if I hear it a different way, it might click a little better.
Yeah, so I explained to you that there's actually a lot of different ways to use the E6B, and there's a lot of different ways to do flight planning. So it's really kind of vague what we're asking about right now. Like in this in this test. So I had a question I asked you guys earlier on the quest test quiz exam final. What did I say? 7.5 minutes. Is that what I asked you about? And that would involve the E6B. So maybe that'd be a simple way to kind of get your brain warmed up to it. So I have a whiz wheel here. It's a very old-fashioned whiz wheel. Everybody, you know, should have a whiz wheel. It's one of the required from day one of the semester. As a private pilot, you should have a whiz wheel. So I didn't invent this thing. It's actually very handy. It does way more functions than I'll ever know. It's a very awesome tool. It's got two different sides to it. The front side is a slide ruler. It's just a slide ruler. You set up a ratio, and then once the ratio is set, move your eyes, not the wheel. Remember, time is always on the inner. So I don't know if I'm barking up the right tree or not for you, Alec, but I have a question on the final that said, how far will an aircraft travel in 7.5 minutes with a ground speed of 114 knots? Is that a question you guys think would be helpful for the whiz wheel?
Yes.
Okay, so we're always going from known to unknown. We're going from known to unknown. What is the known information? The known information, I'm just going to read the question to you. How far will an aircraft travel in 7.5 minutes with a ground speed of 114 knots? So the known information is that we're traveling ground speed over the ground 114 knots. What does that mean? Well, it means that knots means nautical miles per hour. So the ratio that we know is 60 minutes, 114 nautical miles. So we're going to set up a ratio on the whiz wheel that represents 114 nautical miles over 60 minutes. And then once the ratio is set, we will move our eyes, not the wheel. So what you need to think about for us is that a lot of math is based off of a 10 scale. Like, you know, you make it to 0.1, 0.2, 0.3, 0.4, 5, 0.6, 0.7, 0.9. Then when you make it to 10, now we're at 1.0. Or when you go to 1 to 10, then you know, a lot of our, or you make it to 100, or you make it to 1,000. A lot of our math is based off of a 10 scale. But with time, a lot of our math needs to be based off of a 60 scale, the word rate. The word rate implies time. 60 seconds is 1 minute. 60 minutes is 1 hour. So a lot of our math is based off of a 60 scale, not a 10 scale. So what you're going to notice on your whiz wheel is that there's a very large triangle, and that's, see, there's 55, and then that big triangle is my 60, and then there's my 70. The actual whiz wheel does not recognize decimal places. So it could be 0.6, it could be 6.0, it could be 60, you know, 600. It's whatever numbers you make up your own decimal places with the whiz wheel. It involves a little bit of common sense in placement of decimals. So what is known, what's the unknown? The known is that we are traveling 114 nautical miles in 60 minutes. So we need to set up the ratio and spin the wheel and set up the ratio on the slide ruler to be 60 minutes over 114 nautical miles. Remember, time is always on the inner. If you can just tell yourself that 3 times, time is always on the inner. Time is always on the inner. That's probably going to be one of the best things to help you out. And if you ever get too lost, all the instructions are actually written out on the actual face of your E6B. So again, you get these kind of questions, skip them, come back to them later, but literally the instructions are written on the face of your whiz wheel. The instructions are written on the back of the E6B. So the instructions are written on the device. I'm just walking you through it today. So I'm setting you up for 60 minutes, 114 nautical miles. So that's going to involve us spinning the wheel. My wheel is like really old and needs oil, so it's really difficult for me to spin it. But my goal is to set up 114 nautical miles over 60 minutes. Now, there are no decimal places for the whiz wheel. So what you need to do is you need to figure out, how am I going to align 60 with 114? And this is the correct ratio right here that I got it set up. So on the inner scale, you can see the big, large triangle. That's my 60. And on the outer scale, you can see 11 and 12 pretty clearly. So that could be 11 and 12. It could be 110 and 120. It could be, 1.1, 1.2. It's whatever decimal place you need to make it work to set up the ratio. So in this case, I've got it set up for, 114 on the outer. Call that 11 110. Call that 12 120. And if that's the case, each one, oh, I don't have it though. I have it set up for 112. See what I'm saying? It needs to be 114. So I need to spin my wheel slightly. So now you can see that my big triangle is almost directly between the 11 and the 12. There's a larger tick mark there. That would be the exact middle. So like, 115 knots. But I am one tick mark closer to 110. So I'm at 114. So here's 110. 111, 112, 113, 114. I have set up the ratio of 114 knots over 60 minutes. Once you have the ratio set, move your eyes, not the wheel. So in this particular question, we asked the question, how far will an aircraft travel in 7.5 minutes? If we're doing a ground speed of 114 knots. So known to unknown, we know we're traveling 114 nautical miles in 60 minutes. We know that we're going to go travel 7.5 minutes. What's the unknown? How many miles? How many miles are we going to cover in 7.5 minutes? We've already got the ratio set. Move your eyes, not the wheel. So what we need to do is we need to figure out 7.5 minutes. How many miles will 7.5 minutes be worth? Remember, time is always on the inner. Time is always on the inner. Well, on the inner, I got some options of like 5, 5. I got the big 6, 0. I got the 7. I got an 8 or a 70. I got an 80. I got a 90. That 7 could be 70. It could be 7.0 for just 7. It could be 0.7. It could be 700. Something, whatever decimal place you need to work with. It's you make up the own decimal places for the whiz wheel. In this example, we're asking the question, how many miles will we cover in 7.5 minutes? So if I call that 7.0, I call that 8.0, then I would try to find the exact middle. The exact middle would be right here, that tick mark. And right above it, it looks like there's a 14 and a 15. And it looks like what, 14.2? 14.3, 14.2? What do you guys think?
Looks like 14.3 to me.
Okay, 14.3, 14.2, somewhere in that ballpark. And so then the actual correct answer choice, I'm looking at it over here, is 14.25. So if you had set the ratio up correctly and you were trying to debate between some of the answers, and you had an answer choice of 14. You did the math and you thought you got 14.3, and 14.25 was the answer choice. Well, gosh, 0.05 off. That's pretty close. That's when I want to select it. So I don't know if that's helpful or not. I know
Yeah.
Alec asked that.
That one was good. Some of the questions, they'll say like, oh, you're flying from this airport to this airport and you have winds from 30 degrees that are 15 knots, and then you have to tell them what course you would take for that. And I watched some videos on like flight planning with those charts that you can fill out. Could we is that the only way to do that, or?
Okay, yeah. So what's going to happen is I'm going to cover a problem here that Alec wants to hear about. You know, again, these kind of questions are time consuming. These kind of questions involve some extra math. So when you get to this question on the written exam, you skip it and you come back to it later because you don't want to burn yourself out spending all your time doing it. You know, I am looking at our clock and I see that we're at 12:30. So if anybody needs to take off and leave, you know, I'm so happy you guys tuned in. You know, good luck. You know, study hard. You know, let me know what I can do to help you out. For those of you who want to stick around, we're going to tackle a question that Alec wants to go into involving I cross an airport at a certain time and then what time do I arrive somewhere else. I ask you, Alec, is there a particular question that you've been troubled with? Like, did you write down the words that you want to look up and analyze a particular question? Or are you wanting me to try to find one? Or what are you thinking?
There's a bunch of them on the practice tests. I don't have, I'm actually in the car right now.
Yeah, okay. Okay, so if anybody has a particular question, then please speak up. If not, I can try to find one for us. I'm clicking around through my PowerPoint that I made the other day, thinking I might find one. So I have a few different examples here. Let's see if I can show them to you and maybe one of these pops out to you as something you're thinking, Alec. So let me hit this button here. So there's a few of them. Let's see. Sectional viewer. So here's one where it's saying that you're on a cross-country flight and you cross. We covered this one the other day. Magnetic. You said you want wind though. You want one that has wind?
Yeah, the ones with the wind. If you want, I can.
Here, this one you
there
think?
We go. Yes.
This is a stupid long one. I remember this one. So what is the estimated time en route for a flight from St. Marie's Airport, Area 4, to Priest River, Area 1? The wind is from 300 at 14 knots and true airspeed's 90 knots. Add 3 minutes for climb out. Is this one you're thinking?
Yes.
Okay. So this is a little time-consuming problem. I've done this one a few times. So if you're, you know, in a rush or you need to get out of here, I understand, but I can cover this here for us. It says refer to figure 22. So if I back up, that's figure 20. If I go forward, here's figure 20. The idea is that I'm trying to do a flight from Priest River, which is up here, and it's going to go down here to, well, let me just double check it. From Priest River, I'm saying it wrong. I'm confusing my problems. It's from St. Marie's Airport, Area 4, to Priest River, Area 1. So St. Marie's, Area 4, that'd be down here somewhere. And I don't see it because this thing, let me click. There we go. So St. Marie's is down here under my mouse. There's St. Marie's, and Priest River is, I think it's this one right here, Priest River. Okay. So that's the flight path we're going to take. It's kind of northwesterly, if you will. That is our flight. And I go forward or back. Let's see. Click, come on. This one. What is the estimated time en route for a flight from St. Marie's Airport, Area 4, to Priest River, Area 1? And we got the wind. We know our true airspeed. We have to add 3 minutes for climb out. Okay, great. Cool. So what I'm going to start off by telling you, which is a lot of the same information that I posted in that same video on there, but we got you here with us today. You would like to be able to do this with the physical hard copy. And we said this was like figure 22, I think.
Gotcha. Yeah, that makes more sense that I could use the instruments to measure things and all that.
Well, yes and no is what I'm about to tell you. It's
Okay.
like this is what you would want. And if you had a real deal sectional, like a real sectional, then you could use your tools. Like, you know, if you have a plotter and
Right.
the plotter measures the nautical miles, you could put the plotter right up and you could measure. That's what you would do. But the problem is that when you study this chart, it'll tell you the words, and I'll kind of zoom in so you can see it. Down here it says, note, chart is not to scale and should not be used for navigation. Use associated scale. So what you got to pay attention to is up here at the top where my mouse is at.
Yep.
It's actually showing you that there's a different scale. And so this scale, because the chart can get zoomed in or zoomed out, the scale is wrong. So I'll show you what you have to do. What you have to do is you have to use that scale. So you're going to need a blank piece of paper.
Gotcha.
I'll show you what I would do. I would have a nice sharp corner, and I would line up one of the corners with one airport. I'd line up the next corner with another airport, and I make the marks. So I'm lining up St. Mary's to Priest River, and I'm making the marks, and then I'm going to hold it up and show it to you. So I'm just going to hold it up and show you. I'm going to do my best to line it up. So I'm putting my bottom corner on top of that airport. So there's my airport down here at the bottom, St. Mary's.
Yep.
And I got the corner of my paper lined up on the airport. And then at the top of the piece of paper, there's my next airport, which is Priest River, and I've made a mark.
Gotcha.
And so that distance is the distance required. And now what I do is I come up here to the top of my scale. Like it's almost.
See how many times it goes in there.
Yep. So I'll just do that for you real quick so I can keep moving forward.
Is the rest of it just finding out like what the headwind and crosswind component would be compared to your like direction that you're going, and then just apply that? Or
I hear your question, and it sounds like you're trying to cut to the chase. You don't want to sit here and go at this problem for.
Well, yeah.
So I want to answer your question, and so I'm going to try to give you an overview then instead of walking through each particular answer. So
Gotcha.
Let's just read the question one more time then. The question says, how did I find it? Here it is. It says what, or you're not seeing it though. How do I click that button? Click this, then I click this, and then this. And then we're going, click, 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 click. Okay, so here's our setup. We need to know the estimated time en route for a flight from St. Mary's Airport to Priest River Airport. Wind is 300, 14 knots, the true airspeed's 90 knots. Add 3 minutes for climb out. So historically, when I've done this problem before with students, everybody forgets to add the 3 minutes at the end. So you're going to do a whole lot of math, about a half an hour to 45 minutes worth of math. And then at the very end, you have to remember to add those 3 minutes or else you'll never get the right answer. So what is the estimated time en route? Well, it's time, speed, distance math. So what I tell you is on your whiz wheel, my whiz wheel is somewhere nearby. Here it is. On your whiz wheel, it actually kind of walks you through all these steps. And I don't mind walking you through them, but it sounds like you're kind of in a rush. So, you know, you just follow the steps. So step one, you place the wind direction under the true index. So it said the wind was from 300 something or other. So you spin it up to 300 or something, wherever the wind is from. And then step two, it says mark the wind velocity up from the center point. So there's a center hole, and you figure out where the wind is from, and you mark it up. I like to put the center hole at 100 because it's a good, small, even, round number, 100, and then you mark up the certain amount of wind. And then
Gotcha.
it says 3, place true course under the index. So you got to figure out what's the course. What's the course for me to travel from point A to point B, or in this case, to travel from St. Marie's to Priest River. And so the way you figure out course is going to be with the plotter.
Mhm.
And what you could have to do, again, it's almost impossible to do it on a computer screen. But what you do is you try to your best job to line up your plotter, and just to show you, I'm not really in kind of quick and dirty style. I'm going to line it up the best I can, really quick, just to get something going for you. And it looks like I would have to do it like almost there. That looks pretty dang good right there. And then I spin it, and that's pretty solid. So I'm gonna try to hold it still and show it to you. My best, come on. Okay, so what I've done is I've lined up, the bottom is lined up on my airport. So you can see the Priest River Airport. Nope, I'm sorry.
Yep.
St. Marie's. St. Marie's Airport's lined up on the edge of my ruler. And then at the top, it's buried, the Priest River Airport lined up. And what I've done is that hole in the center, this hole in the center is called a grommet, and you would like to line that grommet up with some sort of reference line, whether it's an east and west running line of latitude or a north and south running line of a longitude. You prefer the north-south lines of longitude, but in this case, it's not going to work. So I have lined up my center grommet with a line of latitude that runs left and right. And so I've lined up that line of latitude with my 090. And so now I can see that if I wanted to travel, I think I'm going from south to north, that it would actually be about a heading of 342.
Okay.
And so then you have an idea what the course is going to be, true course over the ground, TC. So then, you're just following the instructions here, and then it says place the true course. So then you spin the wheel to line up your course. And I think you said that we're flying a course of 320 or something like that. And we said the wind was from 300 or something. So it sounds like it's going to be a headwind and it's going to slow us down. We keep reading. It says slide the wind velocity mark to the true airspeed. So earlier we would have created a mark on the whiz wheel, and then you'd slide that mark up or down to the true airspeed. This is a mark that I had from a previous example, but let's say we had an airspeed of 90 knots. Well, you would slide that mark to line up with the 90 knots. Now you can see that the mark is to the right, and so the wind would be from your right, and it'd be slowing you down. You might have a ground speed more of 86. Again, this is not the correct wind mark. We didn't put the correct wind mark.
Sure.
And then you would see, you just keep reading the directions. It says, read ground speed under center, which is what I said. It says headwind correction. It's backwards, gosh. Headwind correction angle between center line and wind mark. So, in this case, the wind is from the right. You see here's 10 and here's 0. So in this case, it looks like, you'd have to correct about 6 degrees to the right to account for that.
Gotcha.
And
That makes sense.
we said that our ground speed was going to get slowed down. So then you have an idea of how fast your ground speed is. Earlier, we showed you the trick where you line up a blank piece of paper and put it into the scale to figure out how many miles. And then you figure out, how many miles it's going to take you. And you know what your ground speed is. And then use this side of the wheel, which, if your ground speed, if you're, let's say you're going slower than 90 knots, so maybe you're going 85 knots, well, then I'd try to set up my whiz wheel for something that would be 60 minutes on the inner to correlate with, whatever the ground speed is on the outer. So here'd be 60 minutes with 85 knots. And then however many miles it was, I didn't get a chance to really do it, but let's say it was 50 miles. Well, miles is on the outer. So then you'd line up whatever outer to figure out your time on the inner. But then you got to remember to add the 3 minutes for climb out, which is what everybody forgets to do. So I feel like some urgency in your voice. I feel like you're kind of wanting me to try to go faster. So I just kind of really quickly went through some of that. if that satisfies you and you're happy with it, that's fine. I don't mind going through the whole problem and spending more time on it in depth and actually running the real numbers.
Sorry, I just lost you for a second. I'm driving around. But yeah, no, I think it's one of those things where last night it was giving me problems, and I woke up today and my brain had already figured it out because none of that seemed too foreign just now.
Yeah, so I mean, driving around's a tough thing, man. You know, like, you know, you got to do what you got to do with yourself. I would, you know, probably try to take my college classes, you know, when I'm not driving around. But,
Yeah.
you know, I agree. You know, math is not easy when we're sitting still, let alone when we're driving. But it sounds like maybe you have a better idea of what's going on. And I think that, you know, I don't mind running through it. You know, if we needed to pull over and, you know, go through it in depth, I don't mind doing that. And if there's somebody else on the line that wants me to see me do the problem truly in depth, I can do that as well. There's another video up of me doing it in depth on a different problem during office hours last week as well. But, you know, it's not just about the one student who's talking, but, you know, as the person who's participating, I want to make sure I get your questions answered. Is there any feedback from anybody? Are you guys all trying to, like, you know, get out of here and say goodbye, or is there another question somebody wants to answer?
I was gonna ask another question.
Yeah, what do you got, Isaac? What are you thinking?
Okay. So last night when I was doing the practice test, I kind of just figured it out. It was the runway landing distances. It's the figure it uses is a really small figure. I'm trying to just find an easier way to do it, and just I figured it out just because the numbers worked out, but just an easier way to do it because it just took me too long.
Did you write down the words? Can you quote me the?
Okay, so I'll give you an idea of what it was. It was oh God, I should have just took a picture of it. If somebody else has a question, that I'm gonna look it up. But if somebody else
Yeah.
has, you can ask.
Yeah, that's about the best strategy we can do because, you know, there's like so many questions in the FAA test bank. Some are old, some are new, some involve old figures, new figures. So it's just really kind of difficult. You know, I could create examples and I could create numbers to just kind of walk you through something, but it may not be as beneficial as like a real example that we might see. You know, I hear you talking about runway landing distances.
Once I bring up the question, it don't make sense. I just gotta pull it up. But like I said, if anybody else has a question while I'm looking for it. Go here.
I have a picture here that I just brought up. You're not seeing it though. Let me try to click that button for you. So here's a picture of a figure 37 airplane landing distance. It's
No,
really
it wasn't.
very similar to the idea that we.
Maybe it was takeoff, but it's just a really small, like maybe it takes up a quarter of what that figure is.
Here's a landing.
Yes, that's it. That's it. So
This
we
is
did
one.
We did it. Yes, we did I did a problem over this. It was saying like using a gross weight of 2,400, pressure altitude of 10,000 with standard temperature. Like it was all over the place. So I eventually figured it out because the gross weight being 2,400, it was a 33% increase. This is how I did it. This is how I did it. Figured out. And I still got the problem right. So for there's a gross weight 2,400. It was a standard temperature. Let me think. It was standard temperature, pressure altitude, was 10,000 feet. And it said, basically with this information given, what would be your takeoff, what would be your landing distance with a 50-foot obstacle?
So I'm trying to comprehend what you're saying, but it's really not making sense because you told me that you really liked this chart here.
Well, it was telling me to use this figure. So it was saying
Yeah.
use 38
But
with an aircraft with a gross weight of 2,400 at standard temperature with a pressure altitude of 10,000 feet. What would be your landing distance?
Yeah, but we're just not saying something correctly because this chart right here, it has the gross weight 1,600. So, and this chart here tells us sea level 2,500, 5,000, 7,500, but this chart doesn't tell us anything about 10,000 feet, and this chart doesn't tell us anything about 2,400 pounds. So this is not the chart for those numbers that you're speaking of. I'm thinking that, we could you can't use this chart because the highest altitude you get is 4,000. So this is about the only chart that I can see that you could use some of those numbers.
Okay.
But I think you were trying to tell me that you don't think it's this chart.
Well, it just, when we went through the question, it was one of the practice tests that you posted on Blackboard.
Yeah.
To use that specific figure and a couple.
This one?
No, it was saying to use the other figure, the smaller one, the other table. I don't know if it just said it was telling me to use the wrong figure or something like that.
We think we got some older questions or something off. So maybe that's part of the problem. So what I tell you with this figure right here, it doesn't make sense. You're talking about 2,400 pounds. This one says 1,600 pounds. So I just don't think you can do any math with this figure for something that's 2,400 pounds or 10,000 feet of altitude. So I don't think you can use this figure. This figure, if you had a tricky question, it could involve like interpolation. So like, for example, 2,500 foot pressure altitude, 5,000 foot pressure altitude. You could have some tricky question where it asks something in the middle. So if I grab my calculator and I added, say I added 2,500 plus 5,000, I'm at 7,500 divided by 2. So like you could have a tricky question somewhere in the middle, like 3,750. And if you had a tricky question involving this chart where it asks what's the data for the middle, 3,750, well, then you could add these numbers together and divide by 2, to get the in-between numbers. But with this chart, we can't do anything that involves 10,000. With this chart, we can't do anything that involves 2,400 pounds or 10,000 pressure altitude. Now, if I go to this chart, we can do some of that math because it has a 10,000 foot pressure altitude level. It has a 2,400 pound airplane. So I'm kind of tempted to think that this chart is what we were thinking about, but without you having the real phraseology or the actual wording of the question, then I'm not really certain. I don't want to lead you astray.
Well, this was the question. It was asked with a gross weight of 2,400 feet at standard temperature with a pressure.
I'm going to type it with a gross weight of 2,400 pounds and what was it?
With a at
10,000?
standard temperature and a pressure altitude of 10,000 feet, what would be your landing distance over a 50-foot obstacle?
So here comes the question.
And if I can find it before you do, I'll.
Oh yeah.
If it'll let me. Yep, it'll let me.
So here's what I found. Determine the total distance required to land outside air temperature standard, pressure altitude 10,000 feet,
that's
weight
the question.
200. So this is the question that I'm seeing. It says reference figure 38, but again, you know, that might be the old figures, and they might have new figures now. This is the figure that they have. They call it figure 38, and it looks like this.
Okay.
If I reference that against the new, see now the newer one says figure 38 is here. So if you encountered this on a newer test and it involved the older test bank questions, you know, they should call it figure 37, but instead of figure 38. So it sounds like that's where some of the confusion is, that the FAA has been updating their figures and their questions. Now my question is this newer graph, figure 37, the exact same? So let's see. It says power, retard, 900 feet per minute, final approach, flaps down, landing gear down. Is that the same information we're seeing here? Retarded, looks pretty similar. So you tell me, Isaac, would you rather see me do it on the black and white copy, or would you rather see it on the color copy?
I'd say the color copy, because
okay, so we'll try to use this color copy right here then. And the question is asking us, determine the total distance required to land. So what I would do, I would just pull out my piece of paper and my pencil, and I would just kind of jot down some of these pieces of data, because that's what we're really going to need to focus on. So when you're trying to study one chart, you're not back and forth. So we said outside air temperature standard. We said pressure altitude. I'm just writing this down on my scratch paper in front of me. 10,000 feet. We said weight pounds is 2,400, and we said wind is calm. I'm breaking my lead. And then we said obstacle is 50 feet. And then I have ABC answer choices. I got ABCA is 1925. I got B is 1450. And I got C is 750. So on my piece of scratch paper, I just kind of, you know, like quickly document, you know, some of those things. So that way I'm ready to try to figure it out. And we're going to open up the figure that's giving you problems, which is this one right here. And the best advice that I can give you all is be sure to, you know, read the figure, any sort of notes. And it's saying associated conditions, you know, it involves this power setting, this flap setting, this landing gear setting, a paved dry runway, approach speed, indicated airspeed is tabulated, brakes maximum. Here's the weights. We said we're going to be 2,400 pounds. So 50 AGL, we should be about 63 knots, call that 72 miles per hour. Now it's showing us an example. So here's an example where they have it in red, the example. So if you ever encountered a chart, you had no idea, you could just follow their example through once to get an idea. Their outside air temperature is 25 Celsius. That's where the red comes up from 25, hits their self a pressure altitude of 3965. So when they get to 3965, they take the corner and they go straight over to the next reference line. If we were at max gross weight, we would not slide down at all. But in this example, our weight is 2814, so the red arrowed line follows down to the 2814 before it slides over to the next reference line. The wind component in the example was 9 knots of headwind. Headwind would decrease your runway requirements, so you slide down following the black slopes until you get 9 knots of headwind, then you slide over to the next reference line. If you needed to clear a 50-foot obstacle, you would follow up the black reference lines for 50 feet of obstacle. If you were asking the question of ground roll only, then you would just go straight across. So now we're ready to tackle it for our particular problem. In our particular problem, we're going to draw in magenta today. We said that we have outside air temperature of standard and pressure altitude of 10,000. So ISA stands for International Standard Atmosphere. So standard is standard is standard. So right here is where the standard temperature meets the pressure altitude of 10,000. So you imagine that, you know, right there is where I would come from straight up, straight down. And it's showing me that, you know, at that pressure, at that altitude, the standard air pressure might be something like -3, -4 degrees Celsius. Not that we need that information. What we're going to do is we're going to go over to the next reference line. So I go straight on over to the next reference line, doing my best job, draw a straight line. It's difficult on my mouse pointer. Okay, now we need to follow the curvature down to our proposed weight. We said our weight is 2,400 pounds. Here's 2,400 pounds on the chart. So if I kind of come straight up, this is the marker I'm looking for. And what I'm noticing is that here's the thick black reference line under my mouse. Here's the next thick black reference line under my mouse. And when you imagine my magenta over here, my magenta, it's not halfway. It's probably like 3/4 of the way between the two thick lines. So maybe 3/4 of the way between the two thick lines might be somewhere in this area. So I might follow that slope down, something like that. And so that means once I hit my weight, I don't need to follow the slope down anymore. It's time for me to shoot straight over. So I'm gonna enter my next reference line somewhere around here. And now we need to account for the next thing, which is pounds. We just did that. Wind calm. If I had a headwind, I'd follow down the slope for the appropriate amount of wind. If I had a tailwind, I would follow up the slope. Really, what you're really realizing here, Isaac, is that at the end of the chart, I'm going to get something called distance. And every time I do a slide action, which takes me higher, I'm going to require more distance. Every time I require a slide action, which brings me lower, I will require less distance. So things like having a higher pressure altitude and a warmer temperature, those kind of things make me slide up on the chart versus things like lower pressure altitude and colder temperatures generally make me slower on the chart. Same thing as weight. Things such as higher weights are going to produce higher runway requirements. Things such as lower weights are going to create less runway requirements. And we just talked about the wind. So the wind we said is going to be calm. So I'm just going to go straight over with that wind. There's no reason to follow up or down because we're not doing any headwind or tailwind. So now eraser. My mouse pointer has failed me again. What a bummer. I'm trying to erase that. Got it. Good job. Okay, let's try it again. I am drawing, and I'm going to draw straight across because there's no headwind, there's no tailwind. It just, goodness, this drawing tool is fighting me today. There it is. I'm drawing. And let's see. Straight over. Right there. Okay. Now you said you want 50-foot obstacle. Yeah. Okay. So we need to follow up these reference lines. And I'm getting a number that's dang near 2,000.
Which would be 1925. 1925 was the answer.
I'm pretty close to 2,000, 1925. So then I would go back and I would look at the possible answer choices. I can do this. How do I click the button? Click this button and this button. Oh, yep, like you said, 1925. So I don't know if that's helpful or not.
I have no idea how I got, because I used the other chart, a whole bunch of math to figure it out, and I ended up getting like 1940 or something like that and still getting that answer, but I don't know how I'm get that.
Yeah, so unfortunately, you know, the FAA updates their test banks. Unfortunately, we see older test bank questions, newer test bank questions. And in this example, I agree. This thing says figure 38. I think that the newer test bank is going to say figure 37. And it would be just like I just walked through you with the magenta line. That would be the most appropriate way to do it. But if you've done math using some other method and you got the right answer, then
no, that's a lot easier. That's a lot easier. Because the way I was doing it, I had to take the gross weight, and it worked out perfectly because it was middle of a third, so it's like every 800 pounds it would increase a third. So I had to multiply whatever score I got by a third, and then on top of that, I had to figure out, okay, so this is the number for standard pressure. This is a number for plus this temperature. This is the number for that plus this temperature. It just happened to work out that it was every increase for the pressure and not the temperature had it increased a certain percentage. So once I figured that out, I multiplied both the percentages by the final number.
Yeah, and I just, all I can do is caution you on that. It's just a written test. It's just ABC multiple guess. So if that's what you did and you got the right answer, so be it. Just in the real world, when you're using real performance charts with real airplanes, that is kind of inappropriate, because the idea is that if you are making assumptions as a pilot, if you make assumptions and you assume things that are actually not truly printed or not truly published by that manufacturer, not truly published in the book, then you're kind of acting like a test pilot, and there's no actual validity, to whether or not that would be the correct amount of runway. So there's not really, no excuse for a pilot to end up trying to use a runway that's too short. So just be careful, if it's, I think that the answer is that we had a confusion of charts and figures. So I think that the most correct answer would be to try to use the chart that has the data in it. But yeah, if you got the right answer, then by all means,
I think, well, no, I don't want to do that. That's the reason why I asked, because I was like, is there an easier way? And I didn't click today that, oh, some of these figures were messed up.
It's a bummer, man. It really is. And that's, Sporty Study Buddy is usually a little better about it, but they still have some bad questions too. The pilots for exams for pilot site, they usually have a lot of the older questions as well. So we're going to do the best we can. There are mistakes on the FAA written exam, unfortunately, but we're just kind of learning the basics of how to do pilot stuff and things.
Okay. Well, I appreciate it.
Oh yeah, for sure. So my goal is not to leave you guys with any questions. We're only down to a few of us here. If you guys are wanting to log off and say goodbye, then I understand. If you guys have any more questions, I'm happy to try to answer or address them.
If nobody else has a question, I'm gonna try and ask more.
Of course.
I gotta look at them. I gotta pull it up, but so another question I had. Let me see if I can pull it up. So here's one. It's this was one that I got wrong, and I couldn't. It just, everything was so close. I think it was just like if you mess up one step, it's gone. It says, what is the expected fuel consumption for a 1,000 nautical mile flight under the following conditions? Pressure altitude is 8,000 feet. Temperature is 22 degrees Celsius. Manifold pressure is 20.8 inches mercury. Winds are calm. So, and I'll write that down. And it says to use figure 36.
Yep. So let me walk you through this one. So I just typed, you said the words out loud, and I just typed them into the internet just to bring up the question. And so Let me show you what I just found myself. I found this one right here. What is expected fuel consumption for a 1,000 nautical mile flight under the following conditions? Is this what you're looking at?
Yes.
Pressure altitude is 8,000. Temperature is 22 Celsius. Manifold pressure 20.8 inches. Wind is calm.
Yes.
Are we all on the same page here?
Yeah, that's what we're looking at.
Now it says figure 36. When you click on that figure 36, I don't get any good information. Is it still figure 36 in the newer book? I don't know. Here's figure 36. No way, it's not. Here it is. It's figure 35 now.
That's
So they changed it. Yep. And I'm not trying to beat you up, but I feel like we covered this one last week in our slideshow. So it's kind of repeating ourselves, but if you need it, then we're going to do it. So the idea is, yeah.
I felt like I did it right, but I still ended up with the wrong answer.
Yeah, sure. Let's just walk
through it. I remember going through it. Trust me.
Yeah, let's walk through it real quick. Let's make sure that we get it. So what is expected fuel consumption for a 1,000 nautical mile flight under the following conditions? Pressure altitude is 8,000. So we know that we want to operate, and I'm just going to pull out myself a blank sheet of paper because that's the best thing I can do. When you start doing a lot of math and there's a lot of numbers, sometimes it's tricky to keep it all straight. So on my blank sheet of paper, I just write down 1,000 nautical mile flight. I write down 8,000 feet pressure altitude. I write down 22 degrees Celsius temperature. I write down manifold pressure of 20.8 inches of mercury, and I write down wind calm. So now that I got this information just written down, just quick rough chicken scratch on my piece of paper in front of me, I'm going to open up the chart. Here's the chart. I'm pointing out to you that we said this is the cruise power chart. And we have three options. We have a standard day. We have a ISA International Standard Atmosphere of -20 Celsius, which means it's extra cold. I have an ISA International Standard Atmosphere of +20 Celsius, which means it's extra warm. We've been told that we're going to operate at 8,000 feet. So here's the 8,000 foot row. This is the 8,000 foot row. And so 8,000 foot, we're searching for a possible 22 Celsius. Well, if I'm up here at this really extra cold segment, it says that the temperature is -19 Celsius. If I am here at the 8,000 foot row and I'm at the standard day, it says that my Celsius is 2. It's 2, just 2 degrees Celsius. But when I get over here on the extra hot day, ISA +20, I get the what we're looking for. And it says that the Celsius is 22 degrees Celsius. So this is where we're going to find the information you're searching for, Isaac. It's saying that it's an extra hot day because it's 22 degrees Celsius, or IOAT, indicated outside air temperature. 22 Celsius, and we're lined up on 8,000 foot pressure altitude. For this information to be valid, we need to have the engine spinning at 2,450 RPM. We need to have a manifold pressure of 20.8, which is what was given to us in the problem, which is further affirmation that we're looking at the correct information. And here's the information that you need to know. It's telling you that the gallons per hour is going to be 11.5. So on my piece of scratch paper, I'm going to write down 11.5 gallons per hour. And on my scratch piece of paper, I'm getting information about how fast we're traveling, TAS, true airspeed. And if I'm going to do this problem in nautical miles, then I would use knots, which is 164 knots. If I was going to do this problem in statute miles, then I would use this miles per hour, 189 miles per hour. In the question, they told us it was a 1,000 nautical mile flight. So we're going to use this nautical miles, knots. So on my scratch piece of paper, I write down 164 KTS. We now have all the information that we need to be able to cover this problem. So the idea is that we're going to go fly 1,000 miles. So we're going to cover ground 164 nautical miles per hour. So I would like to be able to type on the screen to put these thoughts out loud, so that way we can keep track of our math. And I click, and we want to fly 1,000 nautical miles. Okay? I need to make this bigger. Will cover 164 nautical miles per hour. So that's like saying 164 knots. So, great. So what are we going to do? We're going to take our 1,000 mile journey, divide it by 164 knots. And so, using our calculator, we have learned 1,000 division sign 164, 6.09, 6.097 hours to complete the flight. Okay? And we will burn fuel at a rate of, my scratch paper says 11.5 gallons per hour. So I'm at, 6.097 hours times 11.5 gallons per hour equals sign, and I type that into my calculator, and I get 70.121 gallons to complete the flight.
Okay, see, I think I might have bugged something in the calculator, because I did all of this, and I right answer.
Yeah, I mean, it's tricky, man. I promise I didn't create these problems. You know, they're tricky. Sometimes they get you off guard. Sometimes when you do math for an hour or two, you start to hit bad numbers. And, you know, you've seen me. I've done bad math in front of you all before, and I'm embarrassed by it, but it just happens. You know, we're all human beings. We do bad math. And I'm getting an answer of like 7.121 gallons. And then when I look at my possible answers, that's why I would probably choose the 70.1.
Okay. Yeah.
So I think,
Sorry.
No, you got it. Go for it.
I was just saying, see, I did all of this and I don't know. Something happened.
It's a test, man. I mean, it's tricky math, and, you know, there isn't a single pilot alive that tells you they got 100% on their written exam or that they knew every single question in the pilot database. You know, I mean, you know, we all get a little bit better each time we take more tests and practice more problems. And, you know, I'm more than happy to work more problems with you guys if you got some that are troubling you. But I'm not trying to hold you up also if you're trying to, you know, do something else with your day.
No, I mean, I've just been trying to I'm honestly been trying to play catch up with studying because I've been doing nothing but construction work at my grandmother's house, because if it wasn't me and my uncle doing it, nobody would do it right now.
Hey, you know, we got to love grandma, and, you know, you got to make time for all the things that are important in this world, and grandma's important too, and so is class. So, I mean, I want to help you if I can.
All right. Christian, you going to ask a question?
Yeah, I just wanted to see how do you measure or identify like density altitude and pressure altitude on the E6B?
I hear what you're saying, and there's more than one way to skin a cat. There's more than one way to do that math. Do you have the verbiage, the words, so we can look up a particular question to analyze?
No, it was just more or less a general question. I haven't really came across an answer or anything like that that requires me to use the E6B to figure out the density altitude. It was just more for personal knowledge because, I mean, I'm looking at it and this thing looks, it might as well be, you know, Chinese.
Okay, so to answer your question rough and dirty style without a particular math problem to go off of, I tell you a few different rules. I tell you a few different rules of thumb, a few different thoughts to think about. So there's a quick and dirty rule of thumb, and the rule of thumb is simple. Every 1 inch of pressure is equal to 1,000 feet. So like, for example, standard pressure is 299 So if I had a pressure outside that's 29.82, well then my ambient outside pressure is different by 0.1. So 0.1 inch of mercury would be equivalent to 100 feet of altitude change.
Yeah,
That's a rule of thumb. And that rule of thumb may or may not help you so much on the written exam, because the written exam might want to be more technical and more precise. But most pilots, like, you know, are just flying airplanes and not really doing a whole lot of difficult math in the heat of the moment. You should know the rule of thumb is that 1 inch of mercury is worth 1,000 feet. So 0.1 inch of mercury would be worth 100 feet, and 0.01 inches of mercury would be worth 10 feet. So that's kind of the quick and dirty rule of thumb that you could use. And so you asked me the question, how does density altitude relate to pressure altitude? So let's say that Eagle Creek Airport's actually 800 feet above sea level. But for us to just have quick and dirty math, let's say that it's 1,000. Pretend that we are exactly 1,000 feet above sea level. Okay, 1,000, good round number, I like it. And then all of a sudden, the pressure outside today is low pressure. Pretend that it is less dense air, that it is thin air outside. We got low pressure, we got the middle of summer, it's hot. We got all these variables that make the air extra thin. So then maybe you get like an altimeter setting of 29.82. Well, that more thin air, just rule of thumb, quick, rough and dirty, is 100 feet more thin than what it would be if it was standard. So then your density altitude would increase, and maybe the airplane would pretend like it's at 1,100 feet of altitude instead of really being at 1,000 feet of altitude.
Gotcha.
But that's only accounting for pressure. You also have to account for temperature. So at some point, you know, you could involve the whiz wheel. Again, I didn't invent it, but it's really just the fact that you just read the directions on it. So let's say, it's really crazy. So it says, mine says the words, for true airspeed and density altitude, set the air temperature over the pressure altitude. Read the true airspeed over the calibrated airspeed scale. Density altitude in window. I think that's what it says, in the window. So what you would do, and again, you know, it's kind of a lot of extra math for no reason, and we don't have a real example, but the idea is that, like, here's this inner scale, what might show you density altitude. And then over here is where the sliding scales are going to change between air temperature versus pressure altitude. So you could have examples. I don't think there's any questions like this on the private pilot written, but like on the instrument pilot written exam, you have situations where you have to set up outside air temperature. So you're flying at 8,000 feet and the temperature is such and such. So then you would spin the wheel and let's say it was really, really hot that day. Let's use a round number, 10,000. So all of a sudden, if you had a really, really hot day, you're flying at 10,000 feet and my E6B sucks. I need to oil it or just buy a new one. I'm so close. Pretty close right there. So what I've done is I've showed you how you can line up on these inner windows. I've lined up, say it was really hot, positive 40 degrees Celsius with 10,000 pressure altitude. And it shows me that, you know, well, my density altitude might be, you know, 10,000. I don't know, something seems funny about that. Maybe I'm supposed to use this scale over here. Air temperature. Yeah, so here you go. It says, like, say it's a really hot day, positive 50 degrees, that's really hot, positive 50 degrees over top of 5,000, well then it makes me have a density altitude of 10,000. So I mean, there are ways you can use the E6B to figure those things out, but without like a real example, particular question, it's kind of difficult to tackle it. Now, what I will tell you is that on the written exam, the FAA might have some questions about the effects of density altitude, and I have a figure that I could bring up for you if you want to see it. It looks like this. And so you'll probably seen this before if you've been taking some practice writtens. So this is one of the figures that, you know, a lot of people get tripped up at on the written exam. And it's a density altitude chart. And again, it's the same thing I was explaining to you over here, but these are like the more accurate numbers. So like if you got, you know, a change of from standard, what would the pressure altitude conversion factor be? And it's roughly 1 inch of mercury is worth 1,000 feet, but it's a little bit more accurate on this particular example. And then you could run 2 different examples. So like one of the questions on the real written exam is talking like, what is the effect of density altitude, you know, when you run the 2 numbers? And so, you know, like say step 1, you ran the first one and you lined up your outside air temperature with your pressure altitude and you read over and you saw the density altitude. And then you ran another example, and the next example was a different temperature and a different pressure altitude, and you saw a huge increase in density altitude. That's one of the questions on the written as well. So I'm trying to help you out without a particular example. I don't know if any of this is making sense or what your question might be.
It's pointing me in the right direction for sure, because it still doesn't quite, the picture's not quite there, but it is pointing me in the right direction. So, for example, when you were going over the E6B, I realized what those numbers were. So that helps a lot as well.
Yeah, I mean, I don't think you're going to, the simple thing is follow the directions on the whiz wheel. That's the best advice for you. I don't think if you're talking about the private pilot written, which is what you're focusing on, the more questions you probably see are going to involve, this chart. And then you're not necessarily using the rules of thumb anymore. You're using the chart, and you can get even more accurate numbers. Most pilots in the real world don't do this math, because when you call up the AWAS machine and you listen to the local weather machine, we listen to it over the radio, it just tells us what the density altitude is. If it's a really hot summer day, they say, oh, density altitude's 3,000. And you just already know the answer. Oh, density altitude is 3,000 today. You call flight service. The flight briefer explains to you that, hey, today's density altitude is 2,000 feet. So you just already know that even though you're only 1,000 feet above the ground, your airplane's going to, even though you're only 1,000 feet above sea level, your airplane's going to act as if it's 2,000 feet above sea level, regardless of real altitude, because of density altitude. So in the real world, pilots usually don't compute density altitude. That's something that the FAA has got us doing to try to weed out pilots that don't want to take the time to learn how to do some of this math. But I mean, most of the actual real world applications, you're going to hear the density altitude broadcasted to you, or density altitude is already part of the chart to begin with. So we covered some landing and takeoff distance charts earlier. We covered some fuel consumption charts earlier. They already account for density altitude by telling us the temperature information to begin with.
Copy. All right.
So yeah, the E6B manufacturer has created the windows so small because it's really not very everyday practical application that we do that kind of math. But there will be a few questions on the instrument written exam where you'll have to do some of that. On the private pilot written exam, I don't think you're going to be doing a lot of that. You might have 1 or 2 questions that involve the chart that I showed you a few times, but it really doesn't involve you spinning the wheel of the E6B very much.
Okay, that actually makes sense. So I greatly appreciate it. Thank you.
Mm-hmm. So we're down to the last few standing. You guys seem to be the ones that have been studying the hardest and caring the most, is what it looks like. And if you have more questions, I don't mind addressing them. I also am not trying to hold you on the line all day if you wanted to do something else.
No, I don't think I got anything else. Everything that I've been worried about is mostly the mathematic portions of it. Everything else seems to kind of fall in place. So I'm set to go. I don't know about you, Isaac.
No, I mean, I'm good, man. It's just, I'm going to have to do some looking on my own and just practice more, because I'm definitely going to have to do it tomorrow.
Yeah, that's going to be a me thing too.
Yeah, and I'm trying to help you guys out. I gave you a window to take the test, and I got, you got a pretty good time window, 3 hours to work on it. Just remember the strategy that, there's going to be certain questions you just know the answer to real quick. Hit those. And then if it's a question that makes you think or makes you uncertain at all, skip it. Come back to it. Don't waste all your brain power early.
Copy. That makes sense. Thank you, sir.
All right, guys. Have a great day.
You too.
You too.